I'm going to present my screen. Ooh, this screen. Okay. Oh, in terms of taking notes, a few people have asked. What I did, guys, and you should be able to see my screen now. You know, you have like packets to have, like right here, student note blank. Now, I can't get you these. If you have a printer, go ahead, print them out. Do what you got to do. Okay, or you can just write on them in class or in a notebook and then keep them. Remember, you're gonna have a live link to this right here. It says Kami or OneNote, so you can click on this link, and that'll be a live version of what we're doing. Sometimes kids like to follow along using that. Everyone understand that? That's a live link. But if you want something, if you actually want a blank copy, I'll always put a copy in here for you. Okay. One other thing, I don't know how effective it's going to be, but our YouTube channel is up and running. Let's click on it and check it out. Where did it go? Oh, right down here, Algebra 2 Browns. So watch, very fascinating. You have one video from the other day. I will upload them and put them in. So if you miss class, I will always record the videos and put them here, okay? So you can just favorite that, whatever you need to do. Quick update on the NFL. The Cleveland Browns still stink. So we might have to change our header on the page because they are bad. My optimism for the season lasted about 20 minutes, and then I was like, that's it. So if any of you watched football Sunday, the Bills won. So some of you, I'm sure, are Bills fans. I root for the Bills too, but yeah, not a good start to the season. Okay. Any questions anyone has for me? Okay, so let's take out your notes or a piece of paper, something to write on. I did this earlier with my other class. I actually see my 2 Algebra 2s on the same day. So by the time I see you, I've already gone through it once with my other class. So that's good news for you. Okay. And you can kind of follow along. We're just going to go over some factoring today. And remember, the one thing I like about Kami is if I see a video or something, I can upload it right over here. So you have this. Like, here's some factoring notes, factor by grouping. We're going to talk about it. These are quick little extra helpers if you need it. Okay. So it's a resource. All right. So let's see. Factor out the GCF. Hopefully what I talk about today, guys. Oh, actually, shoot. I got to do this real quick. No. Now, let's see if this works. I might have to switch it up in a minute. Okay. Greatest common factor. I always tell kids, you always take out the GCF first. You're going to want to write that down. That should be the first thing you look for when you factor, okay? You should always, always, always be trying to take out the greatest common factor first, okay? 100% of the time, that should be how you factor. Now, let's just practice doing a GCF. 2x squared plus 8x. Now, it's greatest, but it's weird because it's actually the smaller of the two. It's the greatest thing you can factor out of both, if that makes sense. Let me say it again. It's the greatest thing you can factor out of both. So like a lot of kids will say 2x squared, but you can't take an x squared out of the second one. All you can take out is an x. And then that leaves you with x plus 4. Okay. And by the way, how do you check if you factored something right? You multiply it back out. You guys know that, right? You can multiply it back out, distribute. Hold on. I do have to change this. Hold on. I'm going to stop sharing right now. I just have to switch the screens I'm presenting on, because the computer works better on a different screen. Sorry, it's really annoying. Oh, by the way, feel free to use the chat. Okay, hold on. Feel free to use the chat or unmute yourself if you want. That is perfectly acceptable as well. Okay, so hopefully you see it now. The next one, again, it has to be taken out of every term. So I can't take an x out because of the last term, but a lot of you would probably say take out a -4. Be careful when you take out a negative. I'm very big, by the way, guys, on mistake analysis. Okay, I'll often say, what do you think is the common mistake here? And so what happens here is you get x squared minus x plus 1. Does anyone think that's the correct answer? Does anyone want to take a stab at what the main mistakes are right there? What do you think the major mistake is kids make? Anyone want to get? You can unmute or type in the chat. What do you think kids forget to do there? Anyone want to take a stab at it?
The x2.
What do you mean, Ed? What do they do with the x squared?
Forget to factor it in.
Yeah, well, no, it doesn't factor again.
Or yeah,
Megan says parentheses. I was actually thinking, guys, yeah, kind of. Well, Ed, you might be thinking about it, right? I'm not sure. Guys, when you factor out a negative, what had happened to all the signs? Didn't I have to change all the signs? You divide by a negative. So a lot of times kids will forget that. All right. The next one's a little trickier. Ed, do you have a question?
No, sorry.
Okay, that's okay. All right. Do I have a volunteer, a brave soul that wants to try to factor letter C, the GCF? I just want the GCF. So look at letter C. 8x squared y cubed minus 10xy to the fourth. Does anyone want to try that? What can you take out? So you got to take out a number, an x, and a y. Anyone want to take a stab at that? What do you guys think? I can start it. 8 and 10, you can take out a 2. Anyone want to factor the x's and y's for me? No? Come on, guys, you can do it. Oh, someone chat. Let's see. Oh, that's from earlier. Okay.
Would it be 2x in parentheses 4x to the fourth?
Well, hold on. 2x, you can take an x out of each term. Jonas, can you factor a y out of each term? A y to a power?
No.
You can. You have. What can you factor out of each, guys? Y to what power? What could come out of each term? What do you guys think? Anyone want to take a guess at it? Y to the what power? Y to the. Jared says y to the third. Is he right? Y to the third power. See how there's a y to the third, Jonas, and a y to the fourth? That means you can take out a y to the third, okay?
Yeah.
Now, what does that leave you with? Well, you started with an 8. Factoring's like dividing. So 8
4.
divided by 2 is 4. X squared, if you take out an x, you still have 1x left. Now, you have y cubed, and you took out a y cubed. So there's nothing there. You could write a 1 there if you wanted to, but you don't have to. Minus, let's see if we can figure out the next term. Well, you have a 10.
5y.
5. X's go away. Yep. And you have y to the fourth and y cubed, so you have 1y left. And there's your answer. Okay. And by the way, guys, when you say factor, this is where you stop, okay? You don't keep going. It doesn't say solve. A lot of times kids get so excited and want to solve things. No. It's just factor. That's it. Okay. Questions? You guys good with that? Okay. We're going to do a lot of these. Don't worry. Difference of squares. Hopefully this kind of sounds familiar. Difference of perfect squares. Is something like this. A squared minus b squared. Does that look like it sounds familiar? It should. And that factors to a minus b, a plus b. You add them once, subtract them once. I'll show you an example here. Okay. Now, the key here word is difference. Can anyone tell me what the word difference implies? If I say the word difference, what mathematical operation am I talking about? What do you guys think? If I say the word difference.
Subtraction.
Subtraction. Who said that? Joshua. Very good, Josh. Subtraction. It has to be subtraction. I'll show you why in a second. But if you see difference of squares, it's pretty easy. You take the square root. So the square root of 4x squared is 2x, right? The square root of 25 is 5. Hopefully you know square roots. So for this one, you would say, okay, I have 2x minus 5, 2x plus 5. And there's your answer. That's it. You add them once, subtract them once. Does this look familiar to you guys at all? It should, right? Now, does it matter what order you write things in? Could you write the minus and plus? Do you have to write them in a certain order? No. If let's say that, I don't know, Ethan wrote it like this. Just use you as an example, Ethan. That's good. Okay. It doesn't matter. As long as one's added, one's subtracted. And by the way, how do you check stuff? you always multiply out. And what I asked the kids earlier was if they were double distributors or FOILers. Okay. And what I mean is, watch. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Some of you say double distribute and some say FOIL, right? However you remember it. But as long as you know how to multiply. Okay? 5 times 2x is 10x. And 5 times negative 5 is minus 25. You probably haven't multiplied polynomials in a while, but is everyone okay with what I just did there? This is how you check it. Just double distributing, most of you would say. Okay. What happens now? Why does this work? Who can tell me what happens? What happens to those two 10x's?
They get canceled out.
They cancel out, and you're right back to where you started. So you know you did it right. So this is how you would check an answer. Okay? Difference of squares. It's a kind of a tricky little factoring technique. All right. The next one, 49 minus 10x squared. Now, this is the one I thought this always gives kids problems. Take a minute, think about it. Anyone want to take a stab at what they think it is? Jared says 7 minus 10x. You're halfway there, Jared. What would the other parenthesis be? He got it half right. His square roots are 7 and 10x. 7 plus. He's right. So here's how we're going to write it. 7 minus 10x, 7 plus 10x. Now, I asked the kids in the other class, and one of them said 10x minus 7, 10x plus 7. That would be wrong. What I always tell kids with this is order matters. So our brains, I feel like, are like programmed to write an X first, right? We always write X's first. So we're kind of programmed to write X's first, but see how the 49 came first? So I write the 7 first. Okay. So far we've just done GCF and difference of squares. Now, keyword is difference. Here, I'm going to add a little example here. X squared plus 9. Is that the difference of squares? No. What does difference have to have? It has to have a subtraction sign, right? But here's what kids will always say. Oh, x plus 3, x plus 3. But real quick, what happens, guys, is you end up with x squared plus 6x plus 9, which is no good. It's not the same. So there is no factoring for x squared plus 9. You just say it cannot factor. There is no factoring for sum of squares. You didn't learn a sum of squares factoring. You learned difference of squares. Vocabulary is very important, okay? You learned difference of squares. All right. Any questions on that? By the way, did you hear that little thud? A little did you hear that? You did? That's my daughter running around upstairs. She's freaking nuts, but oh well. Okay. Now, real quick, this other kind of factoring, fast factors. X squared minus 12x minus 28. These are where it, like, if you look, when we do quadratics, we have ax squared plus bx plus c. These are where a equals 1. So a lot of times you might just say where it's a 1. Your teacher might have had you write this, multiplies to negative 28, adds to negative 12. Does that look familiar? Just figure out the numbers, you know, and we're going to play around with it. But let's say we have negative 14 and 2. Okay. So then I would have x minus 14, x plus 2. And that's it. There's your answer. Okay. Why don't you guys try really quick B, and then we'll talk about how you would do C. C, you just have to rearrange. So try B and C for me really quick. I think we should have time. See if you can do B and C. Those are just fast factors. If you can do these in your head, go ahead. You don't have to always show me all the steps, okay? If you can do it in your head, absolutely go ahead. And again, if you want to, go ahead, absolutely write it out. Multiplies to 3, adds to -4. I just don't need to see this for a fast factor. Anyone think they have B? Do I have a brave soul? You can either type in the chat or unmute yourself quickly. Anyone want to take a shot at B? You can do it, guys. We're all friends here. You might as well get used to each other. It's going to be a virtual relationships. No one wants to try? Oh, Alina says x minus 1, x minus 3. You guys agree? Yeah, I think her numbers need. I think she's got them right. -1, -3. Might be some others coming in the chat, but yeah, x minus 1, x minus 3, because you had to multiply to a +3 and add -4. Good. Okay, and then how about letter C? Anyone want to try letter C? Oh, someone said. Sydney says x plus 5, x plus 5. Is she right? Okay, good. Now, here's a question. I'm very happy with that. Good job, Sydney. What's another way you could write that? Does anyone know another way you could write that? Sri, did I say that right? How could you write that? You want to unmute yourself? Can you? Do you see it down there?
So x, so just the first part of it and then squared after the parentheses.
Oh, yeah, because there's 2 of them. So you have x plus 5 squared. Now, you don't always have to write it like that, but you certainly can. Okay. You guys good with that so far? Okay. We're actually going to skip. I'll let you get this written down. We're going to skip this part right here. We're going to come back to it in a minute. Okay. All right. So I'm going to go to these that say factor completely. Put a star or something by these if you're writing them down. Factor completely always means you have multi-step. And these were what some of the ones on your problems that I assigned you look like, okay? So you're going to want to make sure you're okay with these. Remember what I always said first. First step, 1, GCF should always be first, no matter what. I yell at my calculus kids about factoring out a GCF first, okay? So anyone have an idea for number 5A? What's a GCF there? What could I factor out of each term?
5.
5. Oh, I see a bunch of 5s coming in. Good, 5. So that leaves me with x squared minus 4. And you have to, like, in the parentheses, you have to keep everything there. So, you know, even if you factored it out, and you can put a 1 there, but you have to represent it, okay? All right. Are you done? Well, no, probably, because it said factor completely. But anyone have any thoughts on how you could continue to factor that? X squared minus 4. Look back at your previous page. Isn't that difference of something? Yeah. Are they both perfect squares?
Mm-hmm.
And it's subtraction. So anyone want to take a shot at what this would be? Josh says 2. Oh, Josh King says x plus 2, x minus 2. Is he right? You
Yeah.
add them once, subtract them once. Difference of squares always becomes you add them once, subtract them once. And there, now it's completely factored. So once you take out the GCF, it becomes, you know, it's usually one of the things you've worked on before. Okay? Are there any questions on that? All right, why don't you guys look at B? Why don't you at least try to factor out the GCF for 5B for me, please? Okay? And I will take a volunteer. Thank you, Sydney. You typed it in perfectly as well. Okay? I'll give you a minute to look at 5B. Does anyone want to attempt to tackle what the GCF is for 5B? What can you take out of each term?
3.
3. Oh, I got a 3 and a 3x. Uh-oh. Anyone want to be a tiebreaker?
3x.
I think whoever said the 3, Jared, but you can also take out an x, right, from everything. So if you take out a 3x, thank you guys. Let's see what that leaves you with. X squared, right? Still x squared minus what? X, 1x minus 12, I want to say.
Yeah.
Okay. Now notice, what have I been doing, guys, with the GCF? Where does the GCF just hang out? Doesn't it? It just kind of stays there, right? It just kind of goes down with the problem. So now you factor this. So again, if you need to write it down, go ahead. Or can anyone in their head think of numbers that multiply to negative 12 and add to negative 1? So now I'm just working on in here. Sydney says x minus 4, x plus 3. Is she right? I think those will work. That'll get you to negative 12 and to negative 1. And there you go. That's your final answer. But again, you have to factor completely. Okay. All right. Questions or how we think so far, okay? All right. Now, down here, there's 2 other types of factor I want to show you really quick for today. Factor by grouping is always, you guys probably have seen this before, but for some of you, this might be a little new. It is always the factoring that has 4 terms. I want everyone to write that down next to factor by grouping. You're always going to have 4 terms. That's how you know you do it. And basically what you do is you factor them in groups of 2, and you try to get the same term twice. I'm going to show you this, okay? And just to, before I do these, just to show you what I was talking about, the one thing I like about Kami is on the previous page, and you have this, here's a video on factor by grouping that I linked into the notes, right? So if you want to look at it while you're doing stuff, and by the way, guys, just for the record, all your tests and quizzes are basically problem sets. So you should just be looking stuff up and like, you know, it is what it is. Okay. Grouping literally means groups of 2. Okay. Let's start with the first group. Sometimes I have kids like draw a little line down if that helps them. What can I take out of the first group? Anyone want to take a stab at that? What can the first group of 6A? So the first 2 terms, if you just had those on the paper, what could you take out of those? X cubed plus 2x squared. What do you guys think? Couldn't you take out an, Jared says an X. Almost, Jared. You're close. Josh says X squared. Jared, you okay with X squared? You good with that? So if you take out an X squared, that leaves you X plus 2. Now watch. You need another X plus 2. So what am I going to take out of the second group? Well, that's the tricky part. What do you got? Anyone want to take a stab at that? Let's see if some things come in the chat. Or you can unmute yourself.
-4.
Who said that? Sri, was that you?
Yeah.
Yeah? -4. Good. That leaves you with an X plus 2. Is she right? Because you got to change the signs. Now, here's how this works. The term that's written twice factors out again, or sometimes I have kids draw an arrow like this. You write that once, X plus 2. The terms on the outside become their own set of parentheses, X squared minus 4. Now, here's where sometimes kids get frustrated. If you did all that beautiful work, and let's say it was worth 4 points, well, let me ask you, is everyone good to there? The terms on the outside become their own set of parentheses. I would give you 3 out of 4. Does anyone want to tell me why a kid would not get full credit? That's really good. What is not done right? Look at where I stopped right there. And this happens all the time. So this will probably happen on some of your papers for the record. Anyone think they know why that's not factored? Why I'm not done? Josh says wrong order. Well, no, actually, no, Josh, the order doesn't matter, but that's a good thought. I appreciate. No, the order actually is okay here. The x squared? Well, what about the x squared, Jared? What's that term? X squared minus 4. Can that factor down x squared minus 4, guys? What's the first type of factoring we did today? Or did we do difference of squares? You see how these kind of like build? So this becomes x minus 2, x plus 2, and then you have another x plus 2. See how that? And if you wanted to be really fancy, you could write x minus 2 times x plus 2 squared. Okay. That's for those of you that want to be really fancy. My sophomores that are enriched, you will get problems like this. Sometimes I expect you to do. And this would be, you know, this would be something I would think you could get. And actually, to be honest, I think all of you should get it, whether you're an enriched sophomore or a regular junior or a senior that just wants to get out of here and graduate Webster Central School District. Okay, why don't you guys start the next one? At least try to take out the GCF of each group and get the same thing twice for me, please, okay? Why don't you guys try B? We only have like 2 or 3 problems left. Okay. Well, let's start with this. What could I take out of the first group, guys? I could take out an x squared, right? That leaves me with x minus 2. And then I could take out a negative 9, and that leaves me with x minus 2. Is everyone okay with that? That's the key part. The x minus 2's get written once, and the terms on the outside get written once. X squared minus 9, they become our own term. Sometimes I would circle those for kids. Now, these 2 examples have more factoring, but sometimes this is where you would stop. I'm hoping everyone is good to hear. Are there any questions how I got to here? Okay. The x squared minus 9 can factor down to, I'm going to bring it down here, x minus 3, x plus 3, difference of squares, and then x minus 2. So that's another one with multi-steps. Okay. Whew. I know. A lot, right? You guys good with that? If you have a question, now's the time to ask. You're going to get a chance to work on these. Okay, real quick, go back to the previous page. Number 4A. This is where A does not equal 1. I had a teacher in high school call them tricky trinomials, and I still call them that. These are the harder ones, where A does not equal 1. So you can't just do multiplies to 10 and adds to 17. So maybe you had a teacher tell you the AC method. Have you ever heard of that? A times C? Because remember, it's ax squared plus bx plus c. So if you multiply 3 times 10, you multiply your first number by your last number. Does that sound familiar? No? Well, watch how it works. What's 3 times 10, guys? 30. Okay? So what you do now is you need numbers that multiply to 30. You do your same trick as before, but you had to multiply. And that's why it's called A times C. And add to negative 17. So instead of multiplying to 10, you do 3 times 10. Oh, and by the way, I would have checked the GCF here. There is, I should make a note, no GCF here. Okay. So now instead of multiplying to 10, they have to multiply to 30 because I did A times C. Okay. All right. So anyone think they know what numbers I would use? I need to multiply to 30 and add to negative 17. Anyone have a thought on that? Josh says, yeah, Josh is right, I think. Negative 15 and negative 2. Just make sure you have them both be negative. Okay, Julia said 15 and 2. Julia, you're right. They just both have to be negative, right? Okay. Okay, so almost done. Now what you do is you take your problem and you say, okay, 3x squared minus 15x. You basically go back to the original and replace negative 17 with these two numbers, minus 2x plus 10. But the key thing is here, you go back to the 10. This works every time, by the way. Or maybe you had a teacher tell you to do guess and check. I don't know, but this works every time. Okay, and then we're going to notice how many terms do I have now, guys? 4 terms, right? Factor by grouping. Watch. 3x, x minus 5. Sorry, I'm trying to write neat. This is tough on this. Can anyone tell me what I could take out of the next group? I want another x minus 5. What do you guys think? What should I take out of the next group? Remember, you need the same term in parentheses twice. What do you guys think I should take out of the next group? Josh says negative 2. Does negative 2 look good? If you take out a negative 2, that leaves me with positive x minus 5. Good. Look, there's your same term twice. You write that once. The numbers on the outside get written once. Let me write that a little nicer. I got to find good colors here, too. I don't know what the best colors that show up are. Oh, that looks good. There's your answer. Okay. A lot of times when they see those, kids will still try to do it at the beginning. Multiplies to 10 and adds to 17. You can't. Okay. So here's the thing, guys. When you're doing factoring, and we're going to pick this up tomorrow, we'll do a couple more. You shouldn't be like, if it's not one of these ways, you're doing it wrong. I don't know how else to tell you that nicely. Okay. All right. Let me talk a little bit about your homework problem. Not homework, but the problem. Yeah, the problems I'd like you to at least kind of practice. Now, there has been some confusion. Not confusion, but like I gave you those Cami problems to look at, okay? So like there, I gave you a few on this page. Like for example, here I'll help you out. Number 14, GCF of x. That leaves you x squared minus 1. Finish it, right? Difference of squares. This was one I asked you to already look at. So this is in the homework packet. If you go down to day 1.2, I just picked a few problems for the kids to try earlier. 1, 2, 3. I'll label them up here. 1, 2, 3, 9. And let's do 5. Well, let's do this. 5, 7, and 9. So I'd like you to at least look at these 6 problems for tomorrow. These are not getting turned in, okay? These are just for you to try to practice on your own. The other ones are getting turned in. You have a Cami assignment. So some of you have to do that, okay? But give those a shot when you get a chance, okay? All right, so I'm going to stop recording now. Well, actually, before I do that, are there any questions on any math stuff? Okay, so let me stop recording.